Here's a question that almost every data scientist or machine learning engineer faces in an interview. How do you handle large datasets efficiently in Python? Now, this question isn't just about knowing the tools. It's about showing how you think when data doesn't fit into memory. Let's break it down. The first strategy is chunking and streaming. Instead of loading an entire dataset at once, you load it in smaller batches. For example, a few thousand rows at a time. You can do this using Pandas by reading the data in chunks, or by using generators that stream one piece of data at a time. This helps avoid memory errors when working with massive CSVs or log files. Next, we have data type optimization. Most people forget this, but changing a column's data type can cut memory usage in half or more. For example, converting a 64-bit integer to a 32-bit integer, or changing long string columns into categorical types, can make your data processing 2 to 3 times faster. Then, there's parallel processing, using libraries like Dask, multiprocessing, or Joblib to split your workload across multiple CPU cores. This is great when you're cleaning or transforming independent data chunks. And finally, out-of-core computing. That's when you use disk-based tools like databases, Parquet files, or memory-mapped arrays, so Python processes data directly from storage, rather than keeping everything in RAM. In short, the interview is testing whether you can think at scale, understand memory constraints, and know when to move from single machine processing to distributed solutions. Let's see how this works in practice. Imagine you're reading a massive CSV file, maybe hundreds of millions of rows. If you try to load it all into memory, your machine will crash. Instead, you read it in chunks. For example, 100,000 rows at a time. Inside a simple loop, you process each chunk. Maybe you're cleaning a column, adding a new feature, and then saving that process chunk to a list or writing it to disk. Once all the chunks are done, you can join them together into a single data frame, or save them to a Parquet file for downstream use. This approach lets you handle datasets far larger than your computer's memory, because you're only working with small pieces at a time. Now let's talk about data type optimization. Suppose your dataset has integer columns that don't need to store huge values. You can safely downcast them from 64-bit to 32-bit or even 16-bit integers. For floating point numbers, you can use a smaller precision type. And for text data, converting long repeated strings, like category names, into Pandas's categorical type can reduce memory by 80 to 90%. Together, these two techniques, chunking and type optimization, can turn a job that crashes your laptop into one that runs smoothly in seconds. Now here's how you could explain this in an interview, clearly and confidently. When dealing with large datasets, I usually combine chunking with data type optimization. For example, while processing a 20 GB clickstream log, I read the data in batches of 100,000 rows, applied transformations to each batch, and downcasted numeric and string columns to save memory. This reduced RAM usage from over 16 GB to just under 3 GB, and cut total processing time by more than half. I also use Dask or Joblib for parallel execution when the job can be distributed, and switch to disk-based formats like Parquet for out-of-core computations. That kind of answer shows you understand scalability, performance tuning, and production-level data handling, and that's exactly what interviewers are looking for when they ask this question.